Hello everyone, my name is Saksham Dikshit and this is my channel Pentest Diary. So today I'll make another video and this is a final video for the Docker security. So in this video itself, it's like there's something like a new concept I'm trying to get it covered, but the thing is that I'll try to make it a concluding video with a lot of details about it, a lot of practical sections for it. I'll try most of the stuffs like which you are aware about it during the series itself, but still I'll try to make it in one video. So this might be a long video where we'll try to get it understand about each and everything about it, what are the practical sections for it. There are a few things which you have not seen it so far in the series, but still I try to get it covered in this video. So this might be a stuff where I just try to conclude a lot of things in one video. So be with me, just go ahead further with that and try to understand each and every section for it. Even this document I'll provide it from my side and I'll put it on a GitHub. You can go through it, all the screenshots, everything, a command also I'll provide it from my side so that you can try to do that whatever you want to do it with this. So that's one of the thing. Other than that, the practical thing also be like the commands are provided so you can use it for the practical purpose also, and the concept you can able to understand. So from the last video where I'm just explaining only theory portion, and this is most of the section is the practical section for it. I'll try to run that commands for you so that you can able to get the details appropriately for it. So going further with that, if you're talking about the what exactly a Docker file is it. So we have seen a Docker file so far in multiple cases, but exactly like when we are running itself over there itself, whatever the type of instructions we're just trying to get it pass. So at the time only the Docker file is generated, like whatever at the time of launching the Docker, like when we are running the Docker itself, we wanted that services or that command to be get it triggered. That thing we are defining inside of the Docker file. So over here itself you can see was what exactly this is the content I'm trying to get it pass. I wanted the hello world to be get it popped. When I try to run it, it will run it with that, and hello world will be get it printed on our screen. Now if I'll try to create an image out of it, then in that case I'll simply have to use this command, and by that way I can able to make that image out of it itself. So that's one of the thing we can try to make it, and we can build that image from the scratch. Now going further with that, if I wanted that file to be like that image which I have built it, I wanted that to be get it run, and when we run it, we'll definitely, like as we have defined it in Docker file, we have defined it hello world. So you can see like when we are trying to run this image, by that way itself, this is the first message we are seeing on our screen. So that's hello world, which we have already defined in a Docker file. That was the reason we can able to print that. So this is all about the Docker file. So such type of concept I'll try to get it covered like with the screenshot so that you can correlate the stuff. Like when we are seeing the practical things, when in that case itself we can correlate the stuff. Like now Docker file is clear to you whenever anyone asks you about it, and if you're seeing any Docker file, you can able to correlate the stuffs very well. Going further with that, if we're talking about the data persistence, so what exactly data persistence itself with the commands also we'll try to get it understand that. So without additional configuration, a Docker container does not have a persistent storage. Its storage is maintained when the container is stopped, but not when the container is removed. So you can stop the container, till then the persistence is there, but if you removed it, it's not there. It is possible to mount a directory on the host in a Docker container. It allows the container to access the files on the host and save them to that mounted directory itself. So like when you're trying to get it copy that, we can do that very easy, not a big deal. So that was one of the thing where we can call it as a data persistence. To have that, like taking example, I'll try to make one file, then I'll just try to run this, and by that way itself I'll just try to make this thing, and then after that what exactly I'll try to read the content. So you can able to see right now I am inside of my host machine itself. Then I'll try and run this, and I'm going inside of that Docker. And now after that what exactly is happening, I'm trying to read this file which I have already created. I'll try, like I have created this file over here itself, and then I'll try to get it passed to this directory, and that I'll try to read it. So when I try to read it, I can able to read the content for it. That's all about the stuffs about it. Okay, so you can see over here itself, I can able to see the content appropriately. Going further with that, networking. So that's also most important thing. Incoming traffic that is not a part of an existing connection is possible by routing traffic for specific ports from the host to the containers. Specifying which ports on the host are routed to which ports on the container is done when the container is created. It's if we, for example, want to expose port 80 to the Docker images created, we can execute the following command. So basically for the networking itself, like whatever port we wanted that to be get it listen and everything, we'll just try to get it configured in such a way. These are the command which we can utilize it just to do the activity for it. So you can see over here itself, we'll build that image first. Then what we have to do, we just have to define it the port on which we wanted that to be get it run, and over here itself 8000:8, and then after that the name of that the name of that image itself, and this is the name of the repository which we are defining it over here, like image itself, and with the name itself we wanted that to be get defined, that we are mentioning, and then the image name itself we are mentioning over here, and then we hit on trigger that. As we have already added that Docker file where we are just printing that echo hello world, then that was the reason when we run it we get the hello world on our screen. Going further with that, if we're talking about the Docker socket, so you're talking about the Docker socket. Docker daemon runs a API 13 that is used by the client to communicate with the Docker daemon. So daemon is one above the host itself, and where on the top of it a container is, like as we have seen in our last video, all the whole diagram itself. So we can see like on the top of the daemon itself we have the container. So that's we are talking about over here. For example, when a user uses the Docker client command, it actually make an HTTP request to the API. By default, the API listen on Unix socket accessible through /var/run/docker.sock, but it is also possible to make it listen for TCP connection, which user are allowed to interact with the Docker. Daemon is defined by the permissions of the Docker socket. To use a Unix socket, a user need to have both read and write permission. We have seen that how exactly we can check the permissions of it, Docker one, so that we have did it. Over here itself, we'll just see that first. Okay, we'll see that listing of it for this directory itself. We'll try to see that. Okay, we can see like who have the right for it, accordingly we can go it further. That was coming under the category of the Docker socket. We can able to see the permissions over here itself as per the need. There is nothing more we can do it on the top of it, but the permission we can see, and the person who is performing that action, that person should have a read and write permission over there. That was one of the thing which is required. We can see over here itself. Okay, for all it's not allowed, for the user it's allowed read and write. That's one of the main thing which you're looking for it. Now going for the Docker group. So what is the Docker group itself? So if we're talking about the Docker group, every user in a Docker group is allowed to use Docker. This allows access management of Docker users. Sometimes a system administrator does not want to do proper access management and add every user to the Docker group, because that allows everything to run smoothly. This misconfiguration, however, allows every user to access every file on the system. Let's say we want the password hash of user admin on the system where we do not have sudo privileges, but we are a member of the Docker group, we can do that. So that's a bigger thing which I can say. If you are a part of the Docker group, then in that case you can privilege with that, and you can see the shadow file of other users also. That was one of the things. So just to overcome that problem, we'll definitely have to get a define appropriate accessibility over there itself for a Docker group, and not all the users be a part of the Docker group itself, as we do not want the whole rights to be get assigned to every user who is accessing the Docker itself. Okay, so that is one of the thing. And running this command itself, we can able to get that control, and then going inside of the Docker itself, we'll run this command by which we can able to read the file content of shadow, and where we are seeing the credentials, and that is one of the thing we can able to see it over here itself very easily. Now going further with that, we talk about the capability. So this is one only for reading that content for it, and if a misconfiguration over there itself, even a user is having accessibility for the Docker, that person can able to see the hash of other users also. That's a problem for us in case of Docker. if we have not configured it appropriately. Going further with that, capabilities. As we saw, in order to perform a privilege escalation, privilege actions in the Linux kernel, a process needs the relevant capabilities. Docker containers are started with minimal capabilities, but it is possible to add extra capabilities at runtime. Giving containers extra capabilities gives the container permissions to perform certain actions. Some of these actions allow Docker escapes. We will look at two such capabilities in the following section. The CIS Docker benchmark cover all these problems and ensure the Linux kernel capabilities are restricted within a container itself. Okay, so that is a capability we're just trying to showcase, like with the privilege action itself, what exactly the actions we can take it. These things is trying to cover under the category of the under the category of the capabilities itself, and there is nothing. A practical section is over here. We have it. Now talk about the capsys and admin. So Docker escape by Felix. The name is Vellum. We need to be run in privilege mode to work, but it can be written to only need the permission to run mount, which is granted by the capsys admin capabilities. So this is the command which we have to run it, and by that way itself we simply have to mount it. Then we have to make a directory over there itself, then we have to make some content over there itself, then we have to run with a host file. This is the thing which I'll try to get it access, and then we have to run this echo1 over there itself, then we have to run this bash1 to cmd, then we have to run this echo psax, like we just trying to get it execute that process auxiliary one. We just trying to figure out with that. We are changing the permission for it, then we are echoing once again for this process, then we are checking that with the output itself. So that's all about the thing. With that appropriate thing, like whole listing about that process, we can able to see on our screen with a screenshot. You can able to correlate the stuffs. Okay. Similar like that for the capsdac read search itself. Before Docker 1.0.0, capsdac read search was added to the default capabilities that a container are given, but these capabilities allow process to escape its containers. A process with capsdac read search is able to brute force the internal index of files outside of the containers. To demonstrate this attack, a proof of concept exploit was released. This exploit has been released in 2014, but still work on containers with capsdac read search capability. So this is also one of the capabilities. Our one is also one of the capability. This is also one of the capability which is required, which is a part of it at the time when we are talking about the Docker 1.0.0 itself. And right now also, like in couple of cases, we can see such type of capabilities over there itself. These are the commands which you can run it just to get it, achieve that. And now you're getting this error over here itself when you're trying to run it. So not the error, it's a warning. I think I'm just getting the warning over there. It's not the error. And if I'll run this file, so after that, when I'll try to execute this file, okay, then after that, if I'll try to get it execute this file, then in that case I can able to see the whole list in front of me itself, and I can able to see the shadow file also. So that is the potential stuff which we can see it very easily using this. So this is also one of the capabilities, and it may be like if it's enabled over there itself, that's a person, attacker or intruder can utilize it as a intrusion point for it. So that's also one of the thing which you have to be aware about it. If this is looks like enabled one on your Docker, then definitely you have to get it disabled. That don't go with that. If you're performing pen testing, this is one of the thing which you can check it. Going further with that Docker socket, which we have already discussed about it, we simply have to run this command, and whatever the running images we have it on our like container is running, we can get the details about it. Then going further with that, we'll simply run this command itself, and with this we can get the whole JSON content in front of us itself. And this file is for the permission itself, just to check the permissions for it, and this we are passing it. Okay, we are running this locally and we get the results accordingly. Now sensitive information. If we're talking about the sensitive information to be get it fetch on our screen, So, like when you're talking about the sensitive information in case of Docker itself, when a container has access to /var/run docker.sock, when /var/run docker is added as a volume inside the container, it cannot only start new container, but it can also look at the configuration of the existing containers. This configuration might contain sensitive information, example password in a environment variable. Let's start a Postgres database inside a Docker. From the documentation of the Postgres Docker image, we know that we can provide a password using the Postgres_password environment variable. If we have access to another container which have access to Docker API, we can read the password from the environment variables. That is the problem over here itself. This is also one of the potential problem which we can get it exploit. So you can see over here itself, we'll try to pass in such a way with a database. Then after that we'll run this, and we simply have to update apt update. Then after that we'll run this command jq, and once we run this command, we are getting this output once again on our screen. So just to get it installed the curl, once it's working, then we are running this command curl just to get the fetch out the output for it, and we can get that output appropriately on our screen. And even I think we can able to see the password also. With the another user, we can able to fetch out the output also using that way. Okay, so that is one of the thing which we can do it, and we can fetch out the password which is stored in the Postgres itself. As just because of the vulnerability present in the Docker itself, we can exploit that and get that secret environment itself where we are storing the password of the Postgres. We can able to get that access. IP table bypass. So the Linux kernel has a built-in firewall called NetFilter, which can be configured with a program called iptables. This firewall consists of a multiple chain of rules which is stored in a tables. Each table has a different purpose. For example, there is a net table for address, translation, and the filter table for traffic filtering, which is a default. Each table has a chain of ordered rules which also have a different purpose. For example, there are the output and the input chains in the filter table that are meant for all outgoing and incoming traffic respectively. Like basically when we are talking about the IP table bypass itself, so we are defining over there itself, IP table itself, we are defining it inbound and for outbound traffic, we are making the rules over there. So that was one of the things we are talking about over here itself, that are meant for the outgoing and incoming traffic respectively. It is possible to configure these rules using a program called iptables. All Linux based firewalls use iptables as their backend. When the Docker daemon is started, it sets up its own chain and rules to create isolated networks. The way it sets up its rules completely bypass other in the firewall because they are set up before the other rules, and by default the rules are quite permissive. This is by design because the network stacks of the host and the container are separate, including the firewall rules. Users of Docker might be under the impression that the firewall rule sets by the host are applicable to every running on the host itself, and this is not the case of the Docker containers and could lead to unintended exposed port itself. So that is one of the thing, we are creating a rules over there itself, but it is not for all the hosts on a Docker itself. That was the reason behind it. When you're running it, you can able to see the details over here itself, and in listing on we first set up the rules to drop all the outgoing including the forwarded traffic on port 80, the standard HTTP port. When we try to request a web page, http://bin.org/cat on the host, as expected the HTTP service is not reachable for us. If we then try to make the exact same request in the container, it works. The CIS Docker benchmark does not cover this problem. It however does have guidelines that ensure this problem exists. So guidelines 2.3 ensure the Docker is allowed to make a changes to IP tables. Recommended that the Docker daemon is allowed to change the firewall rules. That's coming under that. Like we are talking about like the rules are over there itself, and when we're trying to get it manipulate, we can do that. There is a feasibility over that we can manipulate that. So that is also one of the loophole over there itself, where we can modify that IP tables itself, like the ACLs we can modify, and by that way itself we can get the access of those zones which normally we are not supposed to get it access that. ARP spoofing. So talking about the by default, all the containers are added to the same bridge network, and this means they are able to reach each other. By default, the Docker container also receive the CAPNet raw capabilities, which allows them to create a raw packets. This means that by default, containers are able to ARP spoof other containers. Let's take a look at a practical example. Let's say we have 3 containers. One container will ping another containers. A third malicious container wants to intercept the ICMP packets. We started 3 Docker containers using the Ubuntu latest image itself, which is the same as Ubuntu Bionic. Over there itself, we are just defining these: victim 0, victim 1, and the attacker. These are the 3 subsections which we are talking about. We shorten their names to vic 0, vic 1, and the attack. Respectively, instead of cont to indicate in which container a command is executed. So this is one of the thing we have to run this command. Okay, we are going inside of the victim 0. Now inside of the victim 0 we are running apt update. Then we are installing this tool inside of the victim 0. Then we are coming out of it, and now we are going inside of the victim 1. Okay, then after that what we supposed to do, inside of the victim 1 is one of the session, and simultaneously we'll go inside of the attacker. We'll take a session of the attacker also, and now going inside of the attacker itself, go inside of it, then we are inside of it. Then what we have to do, we simply have to run apt update. Now we have to install this tool once again, and now I'll do that ARP spoofing on Ethernet 0 itself, and defining that IP address over itself .0.3. Now what we're supposed to do, if I'll just run with this itself and just make it, I'll just be listening it, and by that way itself in some time I'm getting the hits. Then I'll exit from the attacker system itself, which is session of the Docker, and then after that I'll try to get it connected to the victim 0 once again back. Okay, I'll connect it with that, and I'll just run the ARP over there itself and try to install this tool, running that ARP, and I'm able to see that I can able to see the IP address, like from where we are just seeing the ARP itself. So that is all about the stuff. And now after that, if I'll try to get it connected with the attacker once again, install the TCMP dump, and then I'm running this TCMP dump the -VNI80 ICMP, and then I'm just listening it. So by that way itself, after some time I can able to see some traffic on my machine as a on victim 0 also. I'm just able to see, like when I'm trying to get it ping, in some time itself I'm getting that hits on my attacker system itself from this machine. So that's all about the thing. ARP spoofing is one of the thing we can achieve it, like we have tried with victim 0, victim 1 and attackers over there itself, with couple of combination which we have tried. And with the ARP spoofing, we are putting that the MAC address on in the MAC table of the victim 0 itself. When the victim 0 is trying to ping, at that time only we are just seeing that the packets we can able to sniff it over there itself. So that is TCP dump, we can able to get the details. Now we going further with that, and this is one of the CV. This is first CV, I can say that in case of Docker itself. So far I have not discussed about any CV so far, but this is first CV. It's a CV 20195021. So if I talk about the Docker image for Alpine Linux itself, one of the most used base machine had a problem where the password of the root user in the container is left empty. In Linux, it is possible to disable a password and to leave it blank. A disabled password cannot be used, but a blank password equal an empty string. This allows a non-root user to gain root rights by supplying an empty string, and this is still possible to use a vulnerable image itself. So enable image is 3.3, 3.4, 3.5. So what exactly is happening over here itself? Like in case of Alpine, we have a possibility either to disable, like restrict the password itself, disable the password, or we can make it empty and click on it without password. So in that case, if a normal user trying to get it approach for the root privileges, then in that case that person can get the access of a root as there is no password assigned for that and it's a blank password. That was the reason normal user can get the access over here itself. So you can see, I'll just simply go over here itself, okay, going inside of it, and then I'll run this Alpine sh, then I'll go inside of it, I'll simply run this, and then over here itself add user test, su test, and I can able to run the su root, and I can able to get the root rights over here itself. You can see, so if we have defining a blank password, there is no password for the root, then in that case definitely a normal user as a test user also can get the access of a root. This is all about that. Now I'm going to the next section, that is identifying a container operating system. A lot of things I've covered it so far. I'll just take a minute. Okay, so proceeding further with that, identify the container operating system. Just to get it identify that, we simply have to run this command. By this way we can able to get it identify the whole details about it. To get identifying the operating system of the container, we can get the whole details using this command. We can get the whole details. So this is not the operating system name, okay, this is just an image name. So whatever the image name I'm having it, I'm just mentioning over here itself. Running this command using this, we can able to get the whole detail about the operating system itself as an information. To get the better idea what a container is supposed to do, we can look at the process, because containers should only have a singular task. So we can run this command also from our side just to get the details, and we can able to get the details of the process ID also over there itself. Okay, that's one of the thing. Now identifying the host operating system, I think I have already done that, and using this command also I can do the same thing. I don't think so. Once again, I think it's a repetition. What else? Reading environment variable itself. So whatever the environment variable we have it, we can able to read it very easily. So what we're supposed to do, we simply have to run this command. Using this command itself, I can able to go inside of this environment. I simply have to type env, and then after that I can able to see this, even that whatever the password we have set it, and even like directory, and we are seeing the host name also. So we can able to read the environment variable also using this. Okay, so environment variable are a way to communicate information to container when they are started. When a container is started, environment variable are passed to it. These variables often contain a password and other sensitive information. We can list all the environment variables that are set inside of Docker using the env command itself. So we simply have to go inside of the container, and we simply have to type the command env, and we can able to see the environment variable on our screen. Couple of times we have the secret password inside of it, so that we can retrieve it very easily over there itself. Okay, so checking the capabilities. If we want to check the capabilities, so once we have a clear picture, what kind of systems we are working with, we can do some more details reconnaissance. One of the most important thing to look at are the kernel capabilities of the container. We can do this by looking at /proc/slash/status.5. This is a file contain multiple lines that contains the information about the granted capability. So this is one of the command we have to trigger it just to check the capabilities for it. You're not able to understand much about it, as we have to go in deep depth, and you can able to understand about it what actually the type of capabilities you are seeing over here itself. Okay, with this correlation you can able to figure out the ways like how exactly it's working. Okay, now going further with that, we are interested in cap EFF value, because that value represents the current capabilities. The capabilities are represented as a hexadecimal value. Every capabilities has a value, and the cap EFF value is a combination of the values of granted capabilities. We can use the capsh tool to get a list of capabilities from a hexadecimal value. So this can be run on a different system. So by this way itself you can run it. Okay, I don't have much idea about it, but as I wanted that to be getting included over here, so that was the reason I have included that. I have not have used it so far. That was the reason I'm not having any idea about it. Checking the privileges. So to check the privilege itself, we simply have to run this command, and by that way itself, we can able to check the privileges, whatever privileges I have it over here itself. As started before, if the container runs in a privilege mode, it gets all the capabilities. This make it easy to check if we are running a process in a container is privileged mode or not. So this is the representation of all the capabilities. For if it's running in such a way itself, then definitely it's having all the capabilities right now. Okay, if you are seeing it like when you're running this command, you're getting the output as this, then definitely you can consider it like your process, your container is running in a privileged mode right now. Okay, this is one other thing. And over here itself, you can decode it also. If you want to get it decode, you can able to decode it. By that way you can get the whole details about it. This is a decoding content. When you're trying to get it triggered, you get that output in a decoded one. Okay, the next thing is the checking volumes. So volumes, the directories that are mounted from the host into the containers, are a persistent data to the container. This persistent data might contain some sensitive information. That is why it is important to check that directories are mounted into the containers. We can do this by looking at the mounted file systems location. So this is the command which you have to run it, and by that way itself you can see all the mounted itself over there. It's like with that container itself, whatever the mounted volume over there itself, you can able to see very easily. So that is a command. We'll try to get it trigger over here itself. Now going further with that, checking for a mounted Docker socket. So you simply have to use this command just to check the mounted Docker socket over here itself. Okay, this one you can try to get it see. Now checking the network configuration. Just to check the network configuration itself, even the IP address, you can able to retrieve it very easily. You simply have to run this command. By that way itself, you can able to get that IP address. Okay, and get that configuration details about it. Just to run this once again back, you can update that. You can run the nmap against that IP address also, and you can get the details about it. And even for the pool network also, you want to get it run nmap, you can get the results as per your need. Now the Docker version, if you want to identify the Docker version, you simply have to run the command docker-v. This is also one of the things, like at the time of the enumeration I told you about it. Using this command, you can able to figure out a lot of details about it, like exact Docker version, and if it's a vulnerable one, definitely you can try other possibilities for that version. Who is allowed to use a Dockers? So because having access to the Docker is equivalent to having a root permission, the user that are allowed to use Docker are interesting target. If there is a way to become one of those users, we will essentially have access to everything on the host. As discussed, every user will read and write access to the Docker socket, has permission to the Dockers to use Dockers. That is why the first thing we should do is see which user have read and write access to the Docker socket. By default, root and every user in the Docker group have read and write permissions to the socket. We can see who is in the Docker group by looking in /etc/group. So by that way itself, you can able to retrieve. Like if you want to exploit that, then definitely users have to see, like if you have the root privilege, that's okay, but if you don't have it, then you simply have to target the group, and in the Docker group, whosoever the person is a part of it, definitely you can try to get the access with that. Like by default, a root and the Docker group users having a read and write permissions. So this is a way you can retrieve that details about it, and even if you want to change it, check the Docker itself, you can do that also. I think that's it. So I hope I try my best to cover a lot of things about it. These are a lot of stuffs which I wanted not to be make it a separate video. That was the reason I tried to add everything in one document. I know that these are a lot of things, but the thing is that I have provided the content and even along with the screenshot, so you can able to correlate later also. If you're not able to understand the video in one shot, try to see the video once again. If still, in that case, you can text me on the you can provide your feedback in the comment section of this video, and definitely let me know about it, which section is not like you're not able to understand. I'll try to make the content on it once again back, but I'll try my try my level best to make the content for it, all the possibilities which you can see in case of security for the Docker. So at least you can get it start with the beginners level, and at least it leads to the intermediate level. Now you have understanding on the Docker and container security, how exactly you can utilize it. So everything I try to cover in the whole series itself. This is the final video for the Docker series, and now soon I'll start with a new series itself. So thank you so much once again. If you like this series, please let me know in the comment section with your feedback what exactly the expectation, whether the expectation which you're looking from this series, whether it's fulfilled or not. I'll wait for the feedback for it. Thank you so much once again. Take care. Bye bye.